Hi, I'm Brian. This actually is my, I guess, fourth HOHC, and I'm here today to talk a little bit about DSL. I've been working as a pen tester over the past few years. I basically stopped doing that because I didn't really enjoy it anymore. I've now swapped over to incident response, meaning I've got an epic network that I can just play around in with. And on the other side, I've got by far more time for research. So basically, that's where all this comes from. So why talk about DSL? So over the past few years, as I said, this is the fourth HHC that I'm attending. I gave talks together with Henrik, a good friend of mine, concerning various topics like hardware security, cellular interfaces, LTE and stuff like that. Mainly with the aim of actually giving you as a community all tools and all information that you need to actually start attacking all those technologies that are out there. And basically this year it's DSL's turn. Reason for that is rather easy. I hope it's the same here in Brazil. Is DSL also here the main technology for accessing the internet, or do you have rather cable, something like that? Cable? Okay, bit of both. So for Europe it's usually DSL, and well, you know, DSL networks have grown over the last 10, 15 years, and that's exactly just what they look like. Nobody's really ever had a look at them. They're critical infrastructure, and as such, of course, it's important that being, well, a backbone of communication, that people actually start looking at it. So above that, you've got many countries where actually you can't choose the access point or the router that you want to use. So basically, the ISP will send you a box with the router in it. It will be automatically configured, and that's absolutely it. In Germany, the main issues came up in the moment when many operators switched over to only offering voice and now analog telephone lines, which then meant that people wanted to use custom IP phones and didn't necessarily want to use the router to route all the VoIP traffic through there, which of course then was impossible. Simply due to the fact the credentials are on the box. Of course, you can, do a memory dump and get the stuff from there, but that's not necessarily the nicest way. And so basically coming from the LTE interface, which is on those boxes, is the best, easiest, and nicest approach. And above that, must have been 2016, there was a, let's say, big router outage in Germany, where the telecom speedport routers, many thousands of them actually crashed. And nobody really knew why, until it turned out that it was actually a bug in a worm that was running around. So basically the worm was trying to use something like a shell shock attack to inject code into a router. And funnily enough, this command, when it hit the telecom routers, it would actually just take the attack string and put it into the host's config file, because that's simply they used the addition of an IP address with shell shock to actually attack the devices, and the telecom routers actually just added that attack string into the host's file, and everything broke, so they didn't work anymore. The way that this attack actually worked, it ran over the protocol TR069. Which is one of the main remote control protocols that telecom operators actually use to configure these devices. Yet again, it's a typical DSL protocol, so it's something that we need to have a look at. Basic history, DSL, digital subscriber line or digital subscriber loop. The first versions actually were patented in 1988, so it is already an older technology. And the main aim of DSL is actually to be able to provide high-speed internet via two-wire phone lines, twisted pair lines, simply due to the fact that most houses have the telephone lines going in, and of course you don't want to have to put in new cables to actually provide it. I'd say the first big version of DSL that most people actually started using was ADSL. From 1998, offering up to, 24 Mbit downstream and 3.3 Mbit upstream. And that's actually the difference between up and down, just where the name comes from. So the A in ADSL is asymmetric DSL. In contrast to SDSL, meaning both up and downstreams have the same bandwidth. Whereas, of course, for the typical user, he wants to download stuff, watch videos, so the upstream isn't that important. Unless, of course, you want to start doing stupid things. Nowadays, you've got VDSL, which now is the very high bitrate digital subscriber line. Although it's still called DSL and it still runs over the same wires, it's completely incompatible with each other. So the signal modulation on the lines is simply completely different. As such, it's a new technology, still running over the same wires. Modern VDSL, at least in Germany, goes up to 300 Mbit nowadays. Apparently 100 Mbit upstream, which I've actually never seen. So although they offer it, it doesn't necessarily work. Now, components that we have. The most crucial component of a DSL network is the so-called DSLAM. That's the box that your home modems connect to. So luckily for the talk, I've got a DSLAM here. So this is actually a small, well, semi-professional DSLAM that we'll have a close look at in a bit. In the ADSL times, you probably had something like a single DSLAM for a whole block of houses, maybe even for a whole part of a town, due to the fact that ADSL was able to achieve the bit rate via a distance of between 2 and 3 kilometers, depending on the quality of the lines. With VDSL, they usually have a range of maybe 400, 500, 600 meters only, meaning at least in Germany, Telekom started doing that, I'd say 3-4 years ago. They actually dug holes every few hundred meters and started putting in outdoor DSLAMs, really investing a lot of money because otherwise this technology simply doesn't work. And the DSLAM that I have here actually is there, well, for industrial sites. If you've got something like a ginormous industrial campus and you want to connect both sides and you don't want to put an Ethernet, you simply use the existing phone lines, put the DSLAM, put a modem there, and you've got everything. The most important part of the DSLAM here is it actually controls the communication between the DSLAM as the master modem and the slave device itself. So eventually we'll be running into a few problems with the demo setup, and that's the reason for that. Then the other component that most people actually started off, that's the first part behind the telephone socket, is the so-called splitter. Funnily enough, I don't know how it's here, but actually in Germany, and actually nobody actually knows what it is. Everybody just plugs it in and plugs DSL to the one side and the phone to the other side, and it magically works. So basically what the splitter actually does is it just splits the frequency band that comes in through the two-pin wires and splits it up between the spectrum for the analog line or for the analog phone calls and for the digital communication. And the exact description of that is in the annex. So actually it's called annex because it's the annex of the specification that actually specifies DSL. And what we have here is the, just got to look, the orange part in Annex B, so in the second line, is the whole block that is used for ISDN communication and for analog phone communication. In contrast, in Annex A, if you can see it, there's a very, very small orange block right on the left-hand side, just this tiny bar. That's actually just the spectrum that is really used for analog phone calls. You've got something like, 56-bit, and it is really, just a small band. The yellow block is basically a protection band that just makes sure that none of the frequencies from the high-speed DSL actually interferes with the phone calls. Then you've got the green block for the upstream and the red block going to the end for the downstream. Yet again, you can see the asymmetric part. Nowadays, at least in Germany, typical approach Annex J, you don't have any analog phone lines anymore. So actually the ISPs are running round and, if you don't go for voice over IP, they will basically kill your phone line and it's get a new ISP because they don't want to do it anymore. So the annex always depends on the actual DSL version that is used. and depends on the chipset. So then we have the modem. Yet again, the modem in DSL is basically exactly the same as an analog modem. It's a different technology behind it, but it's just a slave device that is there to actually establish the DSL communication between the client and the DSLAM on the other side. And the client itself, of course, in DSL, typically, it's just a cheap home router, nothing else. Or for some people, like I do it myself, I've just got actually a standalone DSL modem and then just a Sophos UTM on the other side to actually have a proper router that also does something. So from there, lab setup. AllNet 126 AM2 is the DSL modem that I've got here. You can buy them for round about, I think, $230 US. If you go onto eBay, you'll get them for half price. They aren't perfect, so they will only do ADSL2 and parts of VDSL. So if it's a normal, typical old ADSL, then the DSLAM won't work. But for most modern modems, it will actually do the job. The reason that it's got 4 Ethernet ports and everything is basically, it's just a home router with a different firmware and a slightly different chipset in it. So you can actually buy the same thing, which is instead of the AM, it's AS for slave, and you've got your home router from AllNet. So that's exactly the same device. Nice thing about it is it's actually got a serial console, so you can actually go into the Linux that's on there. You've got a small BusyBox terminal. Can do the same with Telnet, which is worth quite a lot as soon as you actually have to automate something, because while you have all the actual IP communication coming out of the DSLAM, all the analog DSL communication stays in the DSLAM and terminates in the modem, so you, in theory, wouldn't still have any access to it. Whereas if you, slightly open the DSLAM, you can also play with that. The CPEs, the one I've got here is a Speedport W921V. It's a home router from Deutsche Telekom. I think it was the standard device that they gave out maybe 4 or 5 years ago. It's not mine, I got it on eBay. As said, I don't really like having those in my house except for breaking them. Above that, basically as a CPE, so the actual end device, you can have a look at whatever you want to. Software-wise, the first thing that you need is a PPP server, because that it's PPP communication running over there, establishing a TUN device. Then you've got the tunnel where the actual IP traffic runs through. It actually took me a while to find a very nice one. The one from Roaring Penguin Software is a small software package with just a few dependencies. You download it, you build it, and it will directly work. Playing with the configuration files isn't that easy. For example, it took me about 4 days to actually get PUB authentication working. Whereas, of course, if you tag something, you just ignore all passwords and everything works. So it doesn't really matter if authentication doesn't work. The other piece of software that is very interesting to look at, even though I've not specifically got it in this talk, is the so-called ACS, the Auto Configuration Server. If you don't know what it is, just look at it as the same way as the backbone component as you have with something like a thin client. So if you have a thin client, you've usually got some magic DHCP parameter that tells the thin client from where to get its configuration, how to boot, and then what sessions to establish. Basically, the ACS is the same thing for on-premise devices of ISPs. Not only routers, but also in Germany, there are quite a few of these set-top boxes that you can connect to your TV. And they also basically use the TR069 protocol to talk to an ACS and are configured that way. So, as said, although I don't have an ACS in the lab setup today, it's important to talk about it because ACSs are real fun. As said, the target node that the modem talks to in the end is simply pushed via DHCP. Meaning we can speak DHCP, so we can push custom servers. and we can make the device talk to us. There are specific vendor options which are all in the specs. So you can just read the specs, set up the whole thing. And so initially the sad thing that you'll see is that there's actually proper authentication there. So usually during initial handshake, which in most situations is SSL encrypted, sometimes it's not, the CPE will actually give the modem or the ACS will give the CPE some kind of secret, and every time somebody wants to configure this home router, you need the secret to get in. So it's secure. At least I've had a few that I weren't really able to break into. On the other hand, there's a very, very fun scenario, because as soon as you start a CPE, most devices come up and they actually connect to the ACS actively. And they say, hey, I'm the home router of whomever, here's my password, let me in. Do you have any new configuration for me? So, you know, if you ignore any kind of authentication, because of course you don't know the password, you just let the CPE connect to you, you let it in, and it's yours. In that moment, although you have authentication towards the CPE so you can't connect to it, as soon as it actually comes to you, you know it's game over. That's just a hint on the side. That's really easy. I've done it a few times in penetration tests. And funnily enough, nobody's really got around fixing that problem. You know, only fix that you'd have would be going for something like certificate-based authentication. So that the CPE will only connect to a valid ACS. But yet again, then you'd have the stupid scenario of basically all home routers in a country having exactly the same client certificate, which would probably be the easiest approach, or the operator actually having to worry about enrolling custom individual certificates to every single CPE that they're running, which yet again, you know, is a lot of work and nobody does it. So, for the basic tools that you need, simple Linux utilities, you know, you need a DHCP server, use something like bind. You will need the VLAN tools. That's actually something that I yet again learned, so I didn't play with it for quite a while, then I switched it back on. And I wondered why not a single one of my approaches actually worked, until I saw the very tiny VLAN line in Wireshark. And I noticed, yeah, okay, you know, if you aren't in the VLAN, then of course the device won't answer. That's something that happens very often if you don't think about it, but it's easily fixed. And above that, you know, if you actually want to attack a home router, you need something like EB tables, IP tables, a DNS server just to reroute basic traffic into your own proxy so that you can basically take it over. And here, really, the nice thing is, you know, everything, as soon as you've got the setup running, is plain IP. So there's no magic going on, there's no whatever creative protocols that they're using. You've got straightforward HTTP. You've got the TR069, which basically is, I think it was something like a JSON format or XML, depending on the implementation. Yet again, that's normal stuff. We can use that. And from there on, it's basic, easy, and simple hacking. So, other tools that you need, as said, problems that you will run into is the moment when you've got a new client and you connect it to your DSLAM and it won't work. You simply won't have a sync between the DSLAM and the modem. Reason for that is that the DSLAM is using the wrong NX, is using wrong encoding, a wrong tone mode, or otherwise said simply the wrong DSL profile. And if you use a DSLAM like that, you've got a long list of profiles, so you're sitting there, drop-down box, profile 1, configuration 1, apply, doesn't work, and you just work your way through, which isn't a lot of fun. Nice thing is with these DSLAMs, as said, you have a telnet interface, you just go in, you write a bash script that automates all those things. So for that, I actually wrote a small script that is able to, let's say, brute force all DSL parameters that are necessary to talk to a modem. It does take, I think, about 2 hours for the whole run, simply due to the fact that whenever the client comes up, it might take up to a minute for the synchronization to work out. Meaning the first time round I did it, I thought, give it half a minute and then that'll be fine. I didn't find a single sync, so I slowed it down and now that's working. Yet again, everything that you can actually automate in a setup like that, write a shell script. Don't ever try to configure the network interfaces by hand twice, because the second time you will do something differently and it won't work anymore. That's just basic experience. So, for the lab setup, I've basically got 3 stages. The first one is everything that you need to actually test a DSL router, which is, well, a DSLAM and the router, of course. Then we've got the full man-in-the-middle setup, meaning you actually have to be able to have your DSL line, the phone line, coming out of the wall. So you need a modem on the other side that you can actually talk to the DSLAM of the ISP. And on the other side, you've got your own home router. So yet again, you will have to go from the DSL, from the home router, into a DSLAM. Then you've got IP traffic again. And then from that DSLAM, you'll have to go into a different DSL modem to redirect it into the phone line, which is basically, I've got another home router for that, which supports PPPoE pass-through, which basically just if PPPoE traffic comes in via the LAN interfaces, just redirects it to the other side and everything's up and running. And then, of course, the last one, the dev setup for man-in-the-middle. I'd recommend, if you start playing around with stuff like that, don't do it on your ISP's network. You will break something, they will mind, and I simply didn't want to take the risk of actually losing connectivity at home. So a proper clean lab for trying, and then, well, I won't talk about the rest. So my basic setup that I have today is my blue VM, which actually isn't the target VM, it's the ISP VM, which I will shift over. So this is a simple Ubuntu VM, which is connected to this blue DSLAM. Basically, I'm going to use this DSLAM to emulate the ISP's network. So it'll talk to the home router. The other VM that I have is, let's see, shift it over. I'm going to do some resizing in a bit. Come on. So much for that. Oh, well, maybe not. Then we'll do it separately. Come on. Sorry for that. I really love multi-screen setups. What we're going to do to start off with, we're going to use the home router that we have and simply use the DSL line to connect it to our DSLAM. Now the part that you can't see is there's a link LED on there, which of course now starts blinking. So the shell, don't worry about it if you can't read it, it's not really that interesting. And obviously the first things that we see, let's just get that a little bit larger, is the PPP traffic from our home router. So basically our main setup or the simple approach is working. This, as said, it's really the DSL line, it's not Ethernet that we're talking to it via, so it's really the information as it goes to the ISP. And of course, coming from here, as I said, the PPOE communication is encapsulated in VLAN 7, which initially I actually thought would be something specific to Deutsche Telekom, but it actually turns out that with most German ISPs, it's always in VLAN 7. So whatever made them choose that. So the next thing that we're going to do is start the PPPoE server. And as quickly as that, we've got a full standing PPP tunnel between our home router and our DSLAM. This basically is everything that you need to go in for a very basic setup. From this moment on, you're in the same situation as an ISP is. You can start scanning the router, you can start attacking the router. So from what I've seen so far from the telecom routers, for example, there's the VLAN 8, which as far as I can remember, they use for IPTV and stuff like that. The VLAN 7 for main traffic, also for VoIP traffic. And just got to think, there actually, which I will show you in a second, is a DHCP request coming out. So actually the home router is sending a raw DHCP request via the DSL line and looking if there's something there, which I've never seen it being answered, but I guess that's for the ACS. So just to get basic configuration. Now let's see if I can hide those VMs again. There we go. So, simple thing, running DSL setup, time to research. Yeah. The next part is the basic man-in-the-middle setup. Meaning we now have the situation that we have the blue DSLAM here, which is our ISP. We've got the white home router there, which is our victim device, and we actually want to get in between. So what we need to do is we need to reconnect the home router that we have to our own DSLAM that we use for attacking. And yet again, the link LED is coming up and starting to establish the communication. So basically, yet again, we are now playing operator. We can see the information coming from the home router, but we've still got to redirect it back into the internet. So the next part that we actually need is we need another modem to, well, reroute the traffic back into the DSL network. As said, that's what my red box here is for. Basically, yet again, connecting the modem that I'm using to the ISP, and I've got a full running lab setup. Whole setup, as said, something like maybe 500 US, and you've got everything that you need. Nice thing about this, as said before, if you use 2 DSLAMs, you can actually play with the text scripts without actually anybody noticing. And you can do it offline in a secure lab environment, which I would highly recommend. So we have our basic demo setup, or the basic lab setup. We are now adding a third VM, which makes this thing even more fun, as you can imagine. where basically we've got two network adapters in there, the one going to the DSLAM, the other one going to the modem, and we simply bridge those two network adapters. This way, all data that comes from the home router goes through the VM and then goes into the internet, which simply is exactly the man-in-the-middle setup that we need. And of course, if we go for Wireshark, we yet again see the PPPoE traffic running through, which basically is the full setup that we actually need to do research. From this moment on, you go in and you use your classic IP tools, as said before, IP tables, EB tables, reroute all the traffic that you have into an attack proxy, and basically either attack your home router or the ISP's network, depending on what you're actually aiming for. So, as sadly I don't have any DSL here, and I'd probably upset somebody if I'd start running attacks against some Brazilian DSL network, if anybody actually notices. Way things go, I did it before, I've prepared it, and I've brought a few things for you to look at. So, full setup, short demo, we've just seen a little bit of traffic. The Telecom DSL router, as said, it's a model from a few years back. It offers VoIP, Wi-Fi. I think it's also got a DECT base in there that you can actually use it for normal phone communication. It's a standard router as you get everywhere in Germany. And as I'm luckily a Telecom customer, I was able to test it at home without messing with any friends' networks. And now we're going to have a look at the PCAPs. Come on. Just hoping that it doesn't break the resolution now. I'm just going to switch it over to mirrored mode so that I can show everything to you easily. So this will either work first try or it will crash the VM. We've got a 50-50 chance. And it didn't crash the VM. Perfect. So much for that. So much for the resolution fitting. Kind of. So this is basically the complete sniff that I did at home from exactly that router connected to our home phone line. The traffic that we have here at the moment is actually a communication between my VM and the DSLAM and the modem that I used for configuring while working on it. So we're just going to let that vanish. So that's less traffic. Just wondering why it isn't properly mirroring again. Okay. Let's give that a second try. Now it's your turn to tell me when to stop zooming in. Yeah? Good. So, this is the full trace, and we're just going to run through it. This green block here is the DSL. So we're going to let that vanish too. The packets that you can see here at the moment are a home automation protocol that my home router speaks and shouts throughout the network. And then at some point, we simply hit the initial PPP handshake. So this yet again is the communication with real Deutsche Telekom in Germany. The credentials that you can see in a second have been changed. I thought about that beforehand. And this actually is the raw authentication request towards an ISP. And as some of you might see, there's a plaintext password there. So that's just what they do. That's the password that you get in your initial letter when you get a contract with the ISP. And as long as you don't start a fight with them, also never changes. So, yeah. Basically, we've got the PPP communication now, we've got the credentials. Maybe a question to you here in Brazil. What do actually the phone line connections in your houses look like? Do they actually come in underground in the cellar, or are they outside on the wall of the house? Outside? Good, it's the same in Germany. You know, that's the moment when you put all that into your black box and snap to phone wires and just hook your setup in between and then run off. That's basically exactly what you do with this. Of course, not recommending doing something like that. Coming from there, we've got loads of traffic. We've got a web browser coming up and talking to stuff. And at some point comes me having a look at updates. So I'm just going to use this filter. And basically the moment when you hit the update button in the home router, this is what you get in Wireshark. You get a communication to a folder called TFTP boot, which basically was, I felt rather lucky when I saw it. Sadly, it's not TFTP, the folder is just called that way. I'd actually hoped to see some TFTP via internet. Basically all this is it fetches, oh, I can't zoom that in. It basically fetches a list of firmware updates that the ACS or a component of the ACS offers. Basically with which route is for, what the version is. There also is a line saying the NS level, which with most updates is set to mandatory. So there also is an option to actually push, well, optional updates that you can go for. Yet again, plaintext, no SSL. Easy as that. After that, probably won't be able to show that nicely. It actually switches over, there we go, which is the DTW91VA, that's the actual firmware file that gets downloaded. As we'd expect, it's unencrypted. So, looks good, looks fun. Sad thing is, with most modern routers, the files are the images are properly signed. So, of course, you know, it being unencrypted, they're not supposed to be being any secrets in there. It's not nice, but it's okay. The same thing, or the other aspect that you can have a look at is zip. So, phone traffic, basic voice over IP. Here, sadly, actually, the authentication, it always works this way. So a zip client runs to the VoIP server, tries to log in, then an unauthorized comes back because they run into a typical digest auth. And as said, it's a digest auth hidden somewhere with anonymous and all credentials that we need. So that's German Telekom. Now let me find my slides again. So yeah, Telekom DSL router, we've had a quick look at it. We've had a look at the PCAP, PPP authentication plaintext, yay. Fetching firmware too, but it's a little bit more secure. Voice over IP. Funnily, actually, most voice phone calls in Germany are unencrypted. That's just the way it's configured. I'm going to skip this PCAP now. PCAP, oh, yeah. The DSL router is exactly the same amount of fun. It comes up, as said, with the PPP authentication, and then it jumps into one line that especially as a crash now. So to explain, I was slightly irritated when on O2 in Germany you established the PPP connection. There's a small, basically welcome message there that I didn't necessarily understand. It actually turns out that the message was in Elvish. So it's actually a quote from Lord of the Rings, speak friend and come in. That's exactly the welcome message that the PPP server from O2, which actually is Telefonica, sends in Germany. So, you know, they obviously have geeks working somewhere. Yet again, with O2, credentials are sent, also VoIP credentials are sent encrypted. I haven't had a look at the phone calls yet. Oh, sorry. Should have said something. Hide that. There we go. But finally, actually, on the router of a friend of mine, although he had actually connected it with his own phone line, there was a second zip connection that just flooded my whole Wireshark sniff with error messages because it's not configured. So whatever they're doing in their default configuration is, yeah, causing random failed logons. Now, what we've seen in theory, it looked bad, you know, with all the plaintext stuff and things like that. In the real world, it shouldn't be a big issue. Simply because usually this traffic stays within the ISP's network. So you've got border gateways, which in theory shouldn't let all that communication out. History has shown it's not always that way. That's exactly the router outage in Germany that I talked about, because they had this ACSTR069 interface exposed to the whole internet, which was actually just a private configuration interface for internal. But that's the way things go. With that, hacking DSL is fun. You should give it a try. If you've got something like that here in Brazil, break it. It will break. Be very careful, especially if you start playing with the VoIP stuff. I just have to say that because we talked about voice over LTE 2 years ago, and you know, zip traffic is typical XML and whatever. And most voice over IP backends support a very great feature which is called SQL injection. You know, don't try to log into a central customer database of an ISP with a drop all tables. It might work, so be careful. Well, yeah, you know, we're relying on all these networks. Nobody's really have had a look at them. The networks, telephone operators networks, they've been out there since they were initially established. And, you know, if you think that somebody will have ever had a look at it, and you know somebody will have ever had a look at critical infrastructure, talk to that guy that's just sneaking by. He will tell you nobody has ever had. Right, Edmund?
That's right. Nobody.
Nobody, so stuff will break, and enjoy yourselves. Thank you. Do you have any questions? Found you.
Thanks for the talk. I have a quick question. Is it traceable from the ISP side? Anything you try to do? Asking for a friend.
Asking for a friend. So the tool development, that's the exact reason why I've got 2 DSLAMs. That's why I'm emulating the whole network, that I can, well, you know, prepare software in such a way that it won't cause any unexpected errors. But of course, you know, the moment you start injecting something, something will break. The man in the middle part, there's no way the ISP can detect it. In this situation, the way I've got the setup at the moment, they might, due to the MAC addresses of the DSLAM. But you know, it's easy to change a MAC address, which then of course I'd recommend. And of course, you mustn't forget that DSL has specific ports for each single customer. Meaning if something comes in through your port, then they know it's you. So if you do something like that, not a recommendation, so off the tape of that, that won't be in the recording, really go in and, you know, call your ISP, say that your port is broken, and they'll just switch you over to a new port. And I bet you they won't have any logging. So you can hide it. So thanks everyone, have a great afternoon. Cheers.